Hello everyone. So today we shall see some definitions. First one is what is called subset. See, we say A is a subset of B when every element of A belongs to the set B, then we can say A is a subset of B, right? Every element of A should be there in the set B, then we can say A is a subset of B. When A is not a subset of B, suppose there is an element in A, but that element does not belong to the set B, even at least one element. If this happens, there is an element in A, but that does not belong to the set B, then we cannot say A is a subset of B. This is the notation for A is not a subset of B. Fine. Okay. So suppose let A be a set, say A, B and C. Fine. Say B is equal to some A and B. Yeah. Here we can say B is a subset of A. Fine. Why? Look at here. Every element of B belongs to the set A. Check it. B has two elements. Here is A. Yes, A belongs to A. Here is B. Yes, this B belongs to A. Right? So every element of B belongs to the set A, then we can say B is a subset of A. Fine. Suppose here is D, one more element. In this case, B is not a subset of A because A belongs to A, this B belongs to A, but this D doesn't belong to A. So not all the elements of B belong to A, right? So here we cannot say B is a subset of A. Fine. Okay. The second one is what is called proper subset of A. Proper subset in the sense, say C is a set has A and B. Before that, we have to note one more thing. Let me ask you one question. Whether A is a subset of A or not. Whether A is a subset of A or not. Check the definition. What is the definition of subset? We can say this set is a subset of this set when all the elements of this set belong to this set. Now you tell me whether all the elements of the set A belong to the set A or not. Yes, of course, it satisfies the definition. So we can say A is a subset of A. See, we don't want to fix any particular A. You take any set. Every set is a subset of itself. It's a very important statement. Every set is a subset of itself because every elements of the set A belong to the set A. Fine. So every set is a subset of its own self, right? Yeah. So what is called proper subset? Here C, this is C. C is a subset of A. Why? Because here A and B, yes, of course A and B are there in A. It is good. It is correct that C is a subset of A, but we can say C is a proper subset of A because C does not contain all the elements of A. C does not contain all the elements of A. A has A, B, C, but this small c element does not belong to this C set, right? Even at least one element of A missing here in the subset, then we can call this set as a proper subset. Even at least one element of this set fails to be here in the subsets, then we can say this set as a proper subset. The notation for a proper subset in some author may use like this, some authors may use like this. We can give more precisely, C is a proper subset of A when C is a subset of A but C is not equal to A. Think about it. Fine. So the third one, what is called power set? What is power set? Now you tell me, say let me take a small set. Say, give me a subset of A. Say, yes, this is a subset of capital A, right? Because this element belongs to this set. This is a subset. This is the subset, right? This is the subset. Are these only the subset? Let me ask you about, what about empty set? What is the relation between empty set and A? Which is a subset of which one? Can we compare it? Yes, we can always say empty set is a subset of any set. Empty set is a subset of any set. What is the argument? See, this is called a vacuous argument, but I don't want to explain these things for school children. If you want it, you can contact me personally. So just take a definition that empty set is a subset of every set. So since empty set is also a subset of A, yeah, I can say empty set is also a subset of A. So these are the only subsets of A. From A, I can make only these many subsets. I can't take any more subsets from A, right? So list all the subsets of A. See, now my set contains sets. So the elements of my new set is set. This is one set, this is one set, this is one set, this is one set. That's why I said the elements of a set could be anything, right? So how many elements are here? This is one element, this is one element, this is one element, this is one element. So totally there are 4 elements in my set. I give a special notation for this. This is called power set of A. What is the notation? What is the meaning of this set? Power set of A means collect all the subsets of A, that is called power set of A. Fine. So we have already seen this formula. If A has 2 elements, how many subsets we can make? How many elements will be there in a power set of A? There are 4. What is the formula we have read already? If the cardinality of A is equal to n, then the number of elements in the power set of A is, what is that? S, 2 to the power n, right? Remember this formula? And I ask the reason why this is 2, why it is not some other number. Okay, thank you.